All right, welcome back. Third video, we're going to just power through two quick examples. The first, excuse me, example is that we are going to go ahead and do the same equations that we had done with cosine and sine, but we're going to change the leading values, the coefficients. We're going to basically be graphing A cosine of t versus B sine of t. So let's dive right into it. 3 cosine of t for our x, 4 sine of t for our y. Our window is going to be 0 to 2 pi as it was. And we're going to, once again, want to do a square graph. So we'll zoom 5 for the square graph. And what we get is something that looks a lot like an ellipse. So our ellipse that we are seeing there appears to have a major axis of 4 in the vertical direction, a minor axis of 3 in the horizontal direction, and wow, that is possibly the worst ellipse I've ever drawn in my life, but we're going to let that go. So let's take a look and see what the equation looks like. We remember that the equation of ellipse is x over a squared plus y over b squared is equal to 1. We know that whichever is larger, a or b, will be the major axis. So let's try this. A cosine of t over a all squared plus b sine of t over b all squared. Sure enough, the a's reduce, the b's reduce. We're left with cosine squared plus sine squared, which is in fact equal to 1. All right, so my students, go ahead and do exercise 13. And let's look at one more quick example. And this example will be x equals 3t and y equals 2 minus 2t from t equals 0 to 1. So again, you can pause and throw that into your calculator. And I will do the same thing here. And time settings 0 to 1 second. And when we hit graph, we get a line segment that runs from 0 to 30. I'm not doing a good job of drawing, but it's because I'm on this touch screen thing. All right, there we go. So what we end up with is y equals negative 2/3 x plus 2 out of that. So let's do one more quick thing just for fun. Let's change this to go from 0 to 2 and see what happens to our graph. And what you see is that we had the exact same line, but it went twice as far in the downward direction because we went to 2 seconds if we were to add that, and there's t less or equal to 2. So as you can see, changing the time changes how long our graph is drawing and changes what we end up with, but not the basic function. All right, excellent. My students, go ahead and do exercise 17, and we will be back. Thanks for watching.